one. Okay, here we have a word problem. The boat can travel 48 miles downstream in 3 hours. If it takes the boat 8 hours to make the return trip back upstream, find the speed of the river current. Okay, can somebody tell me how we're going to start this word problem? What formula do we need first? Okay, anyone with the microphone? This is a distance, rate, time problem, right? So what's the formula, anyone?
Distance equals rate times time.
Good. So we start with distance equal to rate times time. Okay. So looks like we know the time here for the boat can travel 48 miles downstream in 3 hours. Okay, so the time, if you're going downstream, is 3. If you're going downstream, what would be the rate then? Anyone?
48 miles an hour.
No, you divide 3 into 48 times all 8 hours.
Okay, so it says 48 miles. It doesn't say 48 miles per hour here. It says a boat can travel 48 miles downstream. Now 48 miles is a distance. So the distance here is 48. Let's just fill this out here. That would be 48. 48 is a distance that we're going, let's say going downstream. Okay, let's look at the arrow down. Okay. Okay, when you're going to downstream, the rate of the boat and the rate of the current should add up. So you have to let let's see, B be the rate, how fast the boat goes, and let's go ahead and let C be the rate of current. Okay, so if I assume that, what would be the rate here for going downstream, anyone? Okay, when you're going downstream, both of these rates should...
Would it be B? Would it be B plus C?
That's right, Marvin. B plus C. Because the rate of the current and the rate of the boat should add up together, and that would be the rate of the boat together with the current. So one equation here would be 48. That's a distance. Okay, it says 48 miles. It's equal to the rate going downstream would be B plus C, the rate of the boat plus rate of the current, times time is 3. Just give us the 3 hours. Can somebody tell me what would be the second equation here if you're going back upstream? What would be distance? Okay, go ahead, Brian.
The distance would be 48.
Okay, distance will be the same distance, 48. Okay, what would be the rate, Brian?
The rate would be the rate of the boat B minus the rate of the current C.
And what is the time?
Multiplied by the time, 3 hours.
Well, it's not 3, Brian. What is this?
8 hours. Excuse me.
Okay, very good. So, just if it takes the boat 8 hours to make the return trip back upstream, so we're going upstream, the time is 8. The distance is the same, 48. Now the rate would be, the rate of the current would be against us now. That's why we have B minus C. The rate of the boat, how fast the boat goes, minus the rate of the current. So these are the two equations and that we need to have here to solve for B and C. Okay. So how are we going to solve this? Okay, anybody? What would be the first step solving these two equations?
Making both equations equal to each other because they're the same distance, and you're trying to find the speed of the river current.
Okay, so here are the two equations that we have. The first one is 48 is equal to 3 times B plus C. And here we have 48 is equal to 8 times B minus C. Let's go ahead and divide each term here on the first equation, divide both sides by 3. Can I do that? So what do we get if you do that? $48 divided by 3, what do we get?
We get 16.
16 is equal to B plus C. And we can do the same thing here. For the second equation, we have 48 divided by 8. That give me what? Anyway.
6.
6 is equal to B minus. Here we have two equations and two unknown here. We can use addition method. Since the coefficient of C is already opposite of each other, we can just simply add these two. Then we would get C plus C minus C, that would add up to 0. So can anybody tell me what do we get here? Got 16 plus 6.
22.
22 is equal to what?
B.
Well, not B. We have one B here and one B here. A total of how many B's?
2B.
2B. So what is B is equal to?
$11.
Okay, don't forget the unit. What's the unit here then? $11 what?
Miles per hour.
Okay, so the unit is miles per hour. So that would be 11 miles per hour. That's the rate of the boat. But they're asking you what's the speed of the river. So what's the speed of the river, anyone? We can substitute back in either of these two equations, right? We can write 6 is equal to b minus c. Okay, now we know the speed of the boat is 11. So what is c? Subtract 11 from both sides of the equation. So we get minus 5 is equal to minus c. So c must be equal to 5 miles per hour. So that would be the speed of the river. Let's put another example of distance, rate, time problem.